All right, so we are going to continue our conversation about similarity. In the last lesson, you talked about the ways to show that two figures are similar. All right, and notice our standards here. All right, and we're on page 38 here, and this is Unit 6, Lesson 5. All right, standards 14, 1, 2, and 3. I can use my knowledge of similar figures to solve problems involving linear relationships, systems, and quadratics. Now, what this means is that you have to remember the two important things about figures being similar. Two things have to be true each and every time. One is that the sides have to be proportional, and two is that the corresponding angles have to be congruent. All right, both of those things have to be true to tell and know that two things are similar. So, that being said, all right, I want you to pause the video, flip it back on, and let's see, all right, if these two figures are similar. All right, so let's take a look here. Now, you also have to fall back on some of your prerequisite knowledge. So in this case, remember that these markings right here, these arrows mean that these sides are parallel. That also means then we can use what we know about certain types of angles and parallel lines to find missing angles. So one is, if two lines are parallel and crossed by a transversal, we know same side interior angles are supplementary. So if this is 75, this would be 105. And then I could do the same thing here, because notice that these two lines are parallel, and now this side is the transversal. So these two lines, these two angles have to be supplementary. And I can continue that same thought over here. And so what I can see is if I go around the bend here, all right, using what I know about parallel lines and same side interior angles, I can see that none of the angles here are equal to 80 degrees. All right? So these two figures are not similar. The corresponding angles are not congruent. Now, if you match up the sides, now I always write my sides from least to greatest. That way it's easy to match up, right? So notice that if I do that here, it would look like that. And then if I reduce this, all right, this would be 6/5. This would be 6/5. If I divide this by 7, that would be 6/5, and this would be 6/5. All right, so even though the sides are proportional, the corresponding angles are not equal. So this is not a similar figure. All right, so not similar. All right, so now if we go back down, right, if two figures are similar, the corresponding angles are congruent, right? Then you have to make sure that that is true. If two figures are similar, the corresponding sides are proportional, just like we said above. Okay, all right. Okay, so this means that the length, and let me just see exactly, all right. Okay, so this means that the ratio, all right, of corresponding sides are proportional. Proportional, right? Ratio, and I'll put ratio of lengths here. Ratio of lengths of corresponding sides are proportional, right? Okay, and notice that both of these things have to be true, okay, to show that something is similar. Now, if we work that in reverse, right? So if we know that two things are similar, we know that the sides have to be proportional, and we know that the corresponding angles have to be congruent. Okay, so now when we look at a problem like on 38 here, all right, when I look at 38, what that means, right, is these figures are similar. So then I know the sides are proportional, and I know corresponding angles are congruent. So when I look at this, right, I know that I have 28 in this figure, and I have 49, all right, here. Okay, 28 corresponds to 3x minus 4. 49 corresponds to 5x minus 6. And so because they're similar, I can use that piece of knowledge to set up an equation that allows me to solve. And then once again, we know how to solve a proportion. All right, that's why we spent a couple of lessons talking about that. All right, is to make sure that when we got in this situation, we are already good at the mechanics here. We can use that cross-multiplying property, all right, to get to this guy. All right, and then 49 times 3 when I distribute is 147x. All right, and 4 times 49, whoops, get it here, 49 times 4. All right, that would be minus 196. 28 times 5 is 140x, minus, and then 28 times 6 is 168. All right, and so notice now we just get into, all right, our normal solving process here. And I'm just going to do this. And so that leaves me 7x equals, and then negative 168 plus 196 is 28. And so that means x is equal to 4. All right, so notice, right, if we know they're similar, we want to use the appropriate property, all right, to set up the relationship and solve. All right, same thing here. Notice now, though, instead of having information about sides, I have information about angles. All right, and we know the figures are similar. So you have to know the figures are similar, and then you have to know, am I working with sides which are proportional, or am I working with angles which are congruent? Because now, notice, because I'm dealing with angles, right, and if you're uncertain, notice we have the degree symbol here, all right, that tells you that it's an angle. We know that corresponding angles have to be congruent. So we know 6x plus 24 has to equal to 102. All right, so we now know 6y equals, and then I can do 102 minus 24, and that would be 78, and then I can divide by 6, and that tells me that y is 12. All right, or excuse me, I guess that's 13. Let me check that. 78 divided by 6. 13, sorry, 13. All right, so it's very, very important that you know that the figures are similar, because I cannot set up either one of these relationships without this information first. Okay, very, very important. And then once you know they're similar, are you dealing with sides? That's one relationship, proportional. Okay, if I'm dealing with angles, that's another relationship, and that's congruent. All right, let's look at one more problem together. All right, and let's flip and let's see. 38, 39. Let's look at 39 here, page 39, and let's look at number 3. All right, so notice we know zinc is similar to Faux here. All right, and so we know this figure is similar to this figure over here. Now, once again, all right, our drawings, our figures may not be to scale. They look almost equal, but they may not be equal. Okay, so you have to base it on what is stated, not necessarily the appearance of the figure. And notice, if I'm solving for x, notice the information about x. That is on the sides, right? So I know that if I'm solving for x, I need a proportion. Now, notice I can use any of this information, all right, to solve for x. All right, so I just have to find corresponding sides and match them up. All right, so when I look here, right, I can see that, all right, 5 corresponds to x minus 5. So 5 to x minus 5 equals, and then I can see here that 10 corresponds to 30. There's my proportion. And that's one of many that you could set up, all right? So that's important for you to understand as well. So based on the information, you might be able to set up more than one proportion that will lead you to the correct answer. All right? So just understand that when you solve, your answer should match, not necessarily the work, depending on what proportion you solve. Because I could have said 8 to x plus 4. All right? So 8 over x plus 4 equals 11 over 2x minus 7. All right? So I can match up, all right, those things there too. And notice that's a different proportion, but when I solve, I should get the same value for x. All right, so notice now if I cross multiply, I get 10 times x minus 5 equals 150. I get 10x minus 50 is equal to 150. I get 10x is equal to 200, so x is equal to 20. All right, so there you go. All right, and then once again, you can go back and start plugging that in to see if it works, right? So notice I can see my scale factor here, because if I have one, all right, pair of sides, right, with no variables, that gives me my scale factor. So I'm going 10 to 30, so it looks like my scale factor is 3. And so notice if I plug 20 in right here, I get 20 minus 5, which is 15. Well, 5 to 15 is multiplying by 3. If I plug 20 in right here, I get 24. So 8 to 24 is multiplying by 3. Okay, if I plug in 20 right here, I get 40 minus 7, which is 33. So 11 to 33 is multiplying by 3. So once again, you can use what you know to check your work and verify the algebra, which is very, very important. All right, so don't be afraid, all right, when you're done to go back and double check, right? So I can see my scale factor is 3. When I plug in 20, that works. All right, so notice now, solving for y. All right. Now I look at y. Notice y now, these are the angles, all right? And notice I have two pairs of corresponding angles. This angle corresponds to this angle. This angle corresponds to this angle. So that means there were two different relationships I could use to solve for y. It doesn't matter which one you use, all right? So I'm just going to use these first two pairs at the top here. So once again, if I'm solving for y, this is angles, and I should have put here, this is side, so it's proportion. These are now angles, and so now we need congruency, right? Which means we need an equation. So y squared plus 14y equals to 12y plus 24. Okay? And now what I want to do is get into my solving, and I'm going to try to factor this. So I'm going to get it equal to 0, so I'm going to subtract 12y, subtract 12y. I'm going to subtract 24, subtract 24. So y squared plus 2y minus 24 is equal to 0. All right, now I'm not going to go through the entire area model, but if you want to pause the video and go through your area model and factor this to see if you match what I get, that would be great. But if you do it, all right, okay, here's what you should get if you factor correctly, all right? All right, so you should get y plus 6 times y minus 4, and that is equal to 0. So that means y plus 6 is equal to 0. That means y plus 4, or excuse me, y minus 4 is equal to 0. So my first solution is y equals negative 6. My second is y equals to 4. Okay. Now, this is important because notice I do get two solutions. One or both might work. So I always have to go back and check both of them in my equation. So remember when we're dealing with angles, right? There are two things I'm looking for. One, our angles, all right, have to be between 0 and 180 degrees. Okay? All right? So can't be more than 180. Okay, but that also means it can't be less than 0, so we can have no negative angles. So what I'm going to do is I'm going to plug negative 6 in here, right, and see what I get. So I get negative 6 squared plus 14 times negative 6. All right, so notice right there, just on the first check, I get a negative angle. All right, so algebraically, this is a solution. All right, negative 6 is a solution, but in the context of the problem, it is not. All right, because we cannot have a negative angle value. So I know negative 6 doesn't work. So I'm going to go ahead and check 4. All right, let's see what happens when I do 4 here. So to get 4 squared plus 14 times 4, and I get 72. That's great. Now, I should also get 72 when I check here. All right, because they are congruent. So I'm going to do 12 times 4 plus 24. And I get 72 there. Now, I can even go down and check here. That y value should work here as well, right? So if I do this, negative 14 times 4 plus 164, all right, it tells me that angle is 108. Now, once again, it does not look like a 108-degree angle, right? Don't base it on the picture, base it on the math, all right? And I should get 108 here too. So let's see what happens when we do that. And I also get 108 there. So you can see, right, that that solution works. So be very, very good about checking your work, okay? Use the relationships that you know to do so. And then just remember, all right, as you set up these relationships, right, it could be linear, okay? It could be a quadratic relationship. It could also be a system of equations relationship. So make sure you analyze the equations you set up based on those relationships and then solve appropriately. All right, that wraps up our lesson on using similarity to solve. I will see you guys next time.